Hi, this is David from Newton. Let's talk about Venn diagrams and how they can be used in probability. Let's start by talking about the basics of what a Venn diagram is. So here's an example of a Venn diagram representing students who are taking algebra and chemistry. The basic idea here is that by looking at these circles and the way they intersect, we can see how many people take just algebra and not chemistry, how many people take chemistry and not algebra, how many people take both algebra and chemistry, and how many people take neither. So to summarize, we know that 100 students take neither algebra nor chemistry. That's what the number up in the corner means. We have 40 students taking just algebra and not chemistry, so that's the 40 over here that's just in the blue circle. We have 10 students that take both algebra and chemistry. That's the portion of the diagram here, which is in both the blue circle and the red circle. That's the 10 students taking both algebra and chemistry. And then finally, we have 50 students taking just chemistry, not algebra, and that's the 50 students over here that are in just the red circle, not the blue circle. The idea that a diagram like this can help us figure out certain conditional probabilities, and that's what we're going to see next. So again, we have the same diagram. And let's say we're asked, what is the probability that a randomly selected student takes both algebra and chemistry? So the question here is that of all these students, the randomly chosen student, what is the probability that the student takes both algebra and chemistry? So we look to the diagram and figure out this is the portion that we're interested in the probability of. And then we just have to make sure that we're correctly calculating the sample space, the number of students in the denominator. And since we were just asked the probability that a randomly selected student, we weren't given any conditions. So it's just going to be 10 out of the total number of students in the entire diagram. So if we just quickly add that up, we've got 100, 50, 10, and 40, and that adds up to 200. So the probability that a randomly selected student takes both algebra and chemistry is going to be 10. And again, that denominator is all of these, 100 plus 50 plus 10 plus 40. And that all adds up to 200. So 10 out of 200. And if you like, we can reduce that, and this turns out to be 5%. All right, still have the same diagram. Now we're going to ask a slightly harder question. Given that a student takes chemistry, what is the probability that the student also takes algebra? So here we have to be a little bit careful because our sample space now has changed. We were given information. We were given that a student takes chemistry. So what that means is that we want to focus on just the circle for chemistry. We were given that the student has to be one of these students in this circle, one of these 10 plus 50 students, these 60 students. So that given information limits our sample space. So we have to start by focusing in on that portion of the diagram, and then we can say, what is the probability that the student also takes algebra? So now we look within this chemistry circle and say, what portion also takes algebra? And that's this 10 over here that also is in the algebra circle. So the answer here will be 10 out of 60, right? 10 plus 50 is the total chemistry circle. So 10 plus 50. So we get 10 out of 60. Now we're asked, given that a student does not take chemistry, what is the probability that the student takes algebra? So again, we have to be careful to figure out what our sample space is here. So we were given that the student does not take chemistry, so that means we are outside of this red circle. That means our options are over here and up here. Those 140 students are the students who did not take chemistry. So that's our sample space. And now out of those, if we take a student at random, what is the probability that the student takes algebra? Well, algebra is over here. That's the portion we're now interested in, is this 40 students who take algebra. So our answer is going to be 40 out of the total number of students outside of the chemistry circle, which is 40 plus 100. So our final answer is 40 out of 140. Okay, now we're given one last question. Given that a student takes algebra, what is the probability that the student does not take chemistry? So again, we have to pay attention to our given information. We're given that the student takes algebra. So that means we're going to be in the blue circle over here. That's the students who take algebra. And we want to find the probability that the student does not take chemistry. So of these 50 students in the algebra circle, which of them do not take chemistry? Well, that'll be the ones that are not part of the red circles. 40 students in the circle here that are not part of the red circle. So of the students in the algebra circle, the students who take algebra, which ones do not take chemistry? It's these 40 out of the 50 who take algebra. So the final answer is going to be 40 out of 40 plus 10, the total number of students in the algebra circle, which is 40 out of 50. Now let's talk about Venn diagrams with percentages. Now most of the things that we deal with here are going to be very similar to what we dealt with before when we were given the actual number of each item in each region. The only difference here is that we're given now percentages of the total population. So for example, this is the exact same Venn diagram that we've seen in the last few examples. Now we're told that 20% of students take just algebra, 5% take both algebra and chemistry, 25% take just chemistry, and 50% take neither algebra nor chemistry. And again, our calculations will be almost identical. We just have to deal with percentages instead of whatever the units of the sample were before. So as an example, suppose we're given that a student does not take algebra. What is the probability that the student does not take chemistry? So, just like before, we want to focus on the region that is given to us. So if we were given that a student does not take algebra, well, if we did not take algebra, we have to be outside of the algebra circle. So that's going to be out here. We want to know the probability that the student does not take chemistry. Well, the 25% here are the people who took chemistry. The 50% up here are the people that did not take chemistry from within that sample space. Now you have to be careful here because you might be tempted to just put 50% now because that's a percentage, that's a probability. But remember that we have a limited sample space here. Our sample space is limited to these two numbers, the numbers that are outside of the algebra circle. And so what we really want is that 50% in the numerator divided by the total. This is just like what we did before. We have to add the numbers that are outside of, or that are within the limited sample space that we're given. So our limited sample space here being the 50% plus the 25%. So we add those up. And so our final answer is going to be 50% divided by 75%. And we can drop the percentages, and if we wanted to, we could simplify that fraction a little bit more. that comes out to be, if we cancel a 25, a factor of 25 from both, we get 2/3. So that would be a good final answer for the probability.